ionic compounds. Remember that these are formed because you got two ions sitting shoulder to shoulder. They are not holding hands. They are just sitting shoulder to shoulder. So in a covalent bond, they're actually holding hands, essentially. Their little orbitals overlap and link up. In an ionic compound, they're just sitting shoulder to shoulder. They're very powerfully attracted to one another, but they're not physically overlapping. It's an incredibly strong bond. And part of the evidence for this, I've got a chunk here of one of my personal favorite ionic compounds. This is sodium chloride. Can you name, jot down on your paper, don't yell this out, name one of the ions which comprises sodium chloride. Who's buried in Grant's tomb? Name me one of the ions that comprises sodium chloride. Would you like to?
No.
No. Yes. Name it.
Sodium.
Sodium. Name me the other ion.
Like I'm wrong.
No, name me the other ion that comprises sodium chloride.
Carbon.
Chloride. Carbon. Yeah, throw a chunk of sodium chloride at you. So I've got this nice chunk of sodium chloride here. I'll let you pass it around. They are, for the most part, crystalline solids. Question?
I don't know. I just thought that chloride was like...
Chloride is a chlorine ion. We'll talk more about that when we talk about naming conventions. A chlorine atom that's neutral is called chlorine. When it takes on an electron and becomes an ion, we call it chloride. It gets a name change. So, okay. Most of them are crystalline solids. You did a lab last week where you looked at some various substances, some of which were ionic, some of which were covalent. And I think most of you figured out which were which. But the ionic compounds were all crystalline solids. So, what's kind of cool is that when we do a formula for these, we don't do a molecular formula. Why can't we have a molecular formula for an ionic compound? Because it's chemistry. Why can't we have a molecular formula for an ionic compound? Why don't you just go ahead and jot that down? Go ahead and jot that down on your paper someplace. Why can you not have a molecular formula for an ionic compound? It's a great question, isn't it?
I'm sure you can answer.
I think you should jot it down and discuss it quickly first. Engage social networks in your brain. Engage that neural social network.
I guess so. I really got it. Did you say it again?
Why can we not write a molecular formula for an ionic compound?
What is a molecular?
It's a formula for each individual molecule. C6H12O6.
Okay.
Sugar.
So why can't we do that?
Why can't you do that for salt? Oh, you're going to love this. You're going to remember this from last week. Because there are no molecules in an ionic compound. It's a trick question. You can't write a molecular formula for an ionic compound because there are no molecules.
I even wrote that down.
I know. We all repeated it.
Wait, was this on Friday?
No.
No? I didn't write it down.
Oh, okay. It was on Friday.
Not close.
There are
Oh,
no.
no, I did.
There are no molecules in an ionic compound. So we can't write a molecular formula. What we write is actually, we talk about a formula unit. So we're not looking at a specific number of atoms of different substances in a molecule of this stuff. We're looking at the ratio of one kind of ion to another kind of ion.